Hi students. Today, sorry, I couldn't upload the regular class of current electricity. Instead, yeah, there are reasons for that, and I hope I can upload the classes from tomorrow. But I don't want to leave the gap, so I just want you to go through the questions of the test given once. Okay. So most of you have done well. That's good. Being in home, learning everything online, and doing the test this uh, better is very good. Okay, I appreciate your effort in writing the test and uh, gaining good marks. And those who uh, have gained or obtained less marks, no need to worry. You have your own obstacles. You can discuss those things, what are the problems that you are facing, and hence we can sort them out by next test. And so let me go through the questions of the test once, so that you get the clear idea of how to write the answers and the other things related to test. Coming to the first question, first main, what is an electric dipole? For this question, most of you have written the right answer. Two equal and opposite charges separated by certain distance. That's it, right? And some of you have confused it with a definition of dipole moment, electric dipole moment, right? Some of you have written it is the product of magnitude of charge and the distance of separation between them. So that is the definition of electric dipole moment, not electric dipole. Okay, you go through the reference once, you'll get to know that two different definitions are there for these two different terms. You be clear. Okay, so this is electric dipole, not dipole moment. This is two equal and opposite charges separated by certain distance. Okay, and avoid using your own words, your own sentence while writing standard definition and statements. Okay, so you can use your own words when you write the explanation part, right? There you can use it, but when you are writing it in writing the definitions and the standard laws, it's always suggested to write them as the reference that you have. Next is the second one. How does the electrostatic force between two point charges change when a dielectric medium is introduced between them? So this question basically is something which is uh, asking you what happens, right? Or how does the electric force change? So you should mention what is the kind of change that is happening. Many of you have written the right answer, uh, like the electrostatic force decreases, right? That is what happens. But some of you have written the answers in not a straight way, like the force between the charges is inversely proportional to the dielectric medium, the dielectric constant of the medium introduced. That is not the correct answer. That is not the correct answer, or that is not the answer necessary here. Okay, that is right, what you have written is right, but what is necessary here, you should look for what are they asking for. So they're asking you how does the electrostatic force changes. It's a straight answer that you should write is the electrostatic force decreases, right? That is how you should answer. Or they can also ask what happens when the two charges are brought closer. Then you should be able to answer, and then you should be you should answer it as the electrostatic force increases, right? When the charges are brought closer, the electrostatic force increases. That is how you should answer, right? You should the look for what they are actually specifically asking for. And yeah, the answer that you have written, like the force is inversely proportional to the dielectric constant of the given medium. That's also right, but that's not the proper answer for this question. Understood? And if they ask what is the relation or how is the force between two charges dependent on the medium introduced between them, how is the force between two charges dependent on the dielectric constant of the medium introduced between them, if that is the question, then your answer is right. Those who have written it, it's inversely proportional. Okay, but here you should write either it is increasing or decreasing. That is how it should be. Okay, so that is about second question. So, and I have made the answer wrong if you have written um, it is inversely proportional. Okay, because it is not the answer required here. Clear? Next, third question, mention any one method of charging. Okay, so here it's a simple question, very simple question, but the correction that you need to make, some of you need to make, is the complete answer is you have three methods of charging, right? Charging by friction, charging by conduction, charging by induction. You need to mention the complete sentence: charging by conduction, charging by friction. Many of you written simply friction, simply conduction. So no, that is not the way to write the answer. You should write the complete answer. Okay, charging by friction, charging by conduction, charging by induction. Okay, that is how you should write it. Clear on that? And some of you have written by rubbing. Okay, so that is fine, but again, it's rubbing is not the technical word. Okay, now your answer, the marks is in the validator's hand. If he is willing to give, he can give, or else he can deduct the mark. Okay, so rubbing is not the technical word. You should always make use of technical, proper technical words like method charging by friction. Okay, so that is about fourth question. Third question. Fourth is what is the electric potential on the equatorial plane of a dipole? So this is a straight question, for which the answer is 0 volt. Okay, many of you have simply written 0. Okay, that's fine for now. Okay, since this is the beginning, this is the first test. That's fine. But even though it's a numerical value that you are simply putting, you should always mention the units, right? You keep the habit of writing the units whenever you have writing whenever you have answers writing like this. Okay, so the proper answer is 0 volt. Okay, you should mention the unit. You should not forget to mention 0 volt. Fifth is mention the SI unit of capacitance. And here, when you write the SI unit of any unit, any quantity, there are certain rules that you need to follow, right? The first rule is, one of the rule is, you should, when you write that in sentence, and when they ask the questions like this, you should write the unit in sentence itself, in word itself. Okay, not in symbol. Farad, F-A-R-A-D, with F as a small letter, right? Because capital letters doesn't represent the unit, isn't it? So whenever you write, say Newton, you start with small n when you write that in complete word. So avoid using capital letter F when you write Farad. Okay, small f, R-A-D, all of them in small letters, no capitals. So that is one thing you should be concerned. Next is second main. Sixth question, mention any two methods of charging. Again, the same, charging by conduction, charging by friction. You should write that properly, charging by. Next, state and explain Coulomb's law in electrostatics. This statement most of you have written properly, but when it comes to explanation part, many of you have not done that well. So, right, that's an explanation part. You can use your own words, but you should understand the concept, right? Your understanding of the concept should be exhibited. So you just go through the reference ones. There you have the explanation, or you can also write the explanation that I gave in the class in your running notes. Okay, like, that's also fine. You can write that. Okay. Next is sketching the electric field lines. That's fine. Many of you have done well, and some of you have drawn the equipotential surfaces. That's not what I've asked for. Okay, you should draw electric field lines. And here, eighth question, sketching the electric field lines. The first sub question is Q1, Q2 greater than 0, right? And in bracket, I have specified two equal and positive charges. So there, they might not give you that the given charges are positive. Then there are only two possibilities left. When you have Q1, Q2, product of two charges greater than 0, then either of the charge or both the charges must be either positive or negative, right? Then only the product of them can be greater than 0. So there, even if they do not give two equal and opposite charges, you should be able to make out the kind of charge given there. What is Q1, what is Q2, that you should be able to make out. And then Q1, Q2 lesser than 0. Again, I have specified in the bracket two equal and opposite charges. Once again, if even if they didn't give their equal and opposite, you should be able to make out that okay, when you want the product of two charges to be lesser than 0, one of the charge must be positive, the other must be negative, right? That is how. So that is where you should be careful about the eighth question. Even if they didn't give you uh, the, the condition of charges in bracket, like in sentence form, you should be able to make out the or judge the charges, what kind of charges are given. Next, what is an equipotential surface? Give an example. Many of you have written it properly. 10th, what is the potential energy of an electric dipole in an uniform electric field? Okay, when is the potential energy of an electric dipole in a uniform electric field minimum, maximum? So this is about theta, right? You can interpret using the formula itself, right? The formula says U is equal to P cos theta, right? So you just go through the formula, and hence you'll get to know when and even I have shown it with the example of twisting the pen, taking two pens together and twisting them, and you got the demonstration of that. I, Even if you go with the formula, it's U is equal to minus P dot E, right? Minus P cos theta, which will when theta becomes equal to 0 degree, then it has least potential energy. U is very minimum, negative maximum, right? So very minimum when theta is equal to 0 degree, and U is maximum when you have theta is equal to 180 degree, right? So highly unstable. So you should write the answer as when for minimum, when the angle between the external electric field and the dipole moment of the uh, given electric dipole is 0 degree, the potential energy is minimum, and that's the answer for first part. The second part, the answer should be written as the angle between the external electric field and the dipole moment of the given electric dipole equal to 180 degree, right? That is when it is maximum. Okay, that is how you should write the answer. And at the same time, this question can also be asked in like when is the electric dipole highly stable and highly unstable in the external electric field. Okay, so the same kind of answer. For minimum potential energy, it is highly stable. For maximum potential energy, it is highly unstable. That is how you should write the answer. Okay, that's the other way of asking the same question. Next, on what factors does the capacitance of the parallel plate capacitor depends? That's good. And here some of you have written simply the symbols, right? This is the formula is C is equal to epsilon naught A by D. Many of you have written simply epsilon naught A and D. No, no, that is not how. That is not you should. That is how you should be writing the answer. You should write that the permittivity or the relative permittivity of the medium between the plates, and the area of the plates and the distance between the plates. Okay, that is how you should be writing the answer. Next, Third question, mention any three properties of electric charge. Straight answer. Okay, three properties. And yeah, prefer writing the basic properties like charges are additive in nature, charges are quantized in nature, charges are what is conserved in nature, right? So these three are basic. Avoid writing the other one, other properties. Okay, yeah, they are right, but these are the basics, they're standard. Okay, you always practice writing these first. You write them but as the extra points. Okay, like other points are uh, like charges repel each other, unlike charges attraction. Yeah, that's a basic property you can write. Okay, there are other certain properties. um, Keep them as the last preference, but you concentrate on these basic charges. Okay, and write that in sentence form properly. Many of you are written simply conserved, additive, quantized. No, that doesn't make sense. So you should write charges are conserved in nature, charges are quantized in nature, charges are additive in nature. I am not asking you to write the explanation part of it, it's just the main point, right? So you should be able to write at least that much. You should have that much patience. Next is expression for torque, a standard derivation. You should go through the reference and get to know. And whenever you are deriving something, when you are writing a derivation, draw the diagram properly. Okay, because the rule is uh, any derivation without proper diagram will carry no mark. Okay, you will be awarded 0 mark for the derivation if you have not drawn the diagram properly. Okay, so draw the diagram properly, then do the derivation. Okay, many of you have not drawn the diagrams properly, that is why. Okay, next is 14th, write any three characteristics of electric field. Standard one you can write. uh, 15th, derive the relation between electric field and electric potential due to point charge. Yeah, this is again standard derivation. You should be writing the diagram properly. Many of you are confused with the diagram of this derivation. Okay, the two planes and the potential difference should be writing. Okay, next is derive the expression for capacitance of a parallel plate capacitor. This is the derivation of C is equal to epsilon naught A by D. Okay, so standard one again. Next, 17th, write the electrostatic properties of conductors placed in electrostatic field. Yeah, this is the standard properties that you have, like 5 to 6 properties that you have. Electrostatic properties of conductors. You can list them. Okay. Next is standard derivations. Fourth main, question number 18. Derive an expression for electric field due to an electric dipole. Okay, derive an expression for electric field due to an electric dipole at a point on the equatorial line. So equatorial line standard derivation should be able to right. Again, this derivation plays the diagram plays very important role. Okay, you take as much space as you want. Okay, draw the diagram bigger, because this particularly this 18th question requires bigger diagram, right? So draw it carefully and properly. 19th, yeah, state Gauss law in electrostatics and derive the expression for electric field due to uniformly charged thin spherical shell at a point outside the shell. So this question, many of you have not written, not many, some of you have not written the Gauss law statement itself. You have directly gone to the statement and directly gone to the derivation. Not sure whether you have misread it or skipped it, not learned, not sure of it. But stating Gauss law carries 1 mark, and the derivation carries 4 mark. And even in derivation, diagram is must. Without diagram, again, you'll get 0 out of 4. So 20th is derive an expression for electric field due to an electric dipole at a point on the axial line. Okay, axial line derivation, standard one. Again, in this diagram problem itself. Okay, some of you have not run the diagram properly. Take care of that. 21st, define electric potential due to a point charge and arrive at the expression for the electric potential at a point due to a point charge. Again, definition of electric potential carries 1 mark and the derivation carries 4 mark. So Again, should be careful on that. Next, obtain the expression for effective capacitance of two capacitors connected in parallel and in series. So you should write both the derivations. Normally in board exams, the question won't be asked in this kind. They can, what they do is they put either parallel or series in 3 mark question. Since I should have I should, yeah, I was in a situation to give 5 mark question from capacitor part, so I gave this combination, or I gave both series and parallel together for 5 mark. Okay, some of you have not read the second part, some of you have derived only the parallel case and not done the series case, so careful on that. Do that. That is question number 22. Then it's about problems, numerical one. Question number 23. So it has 2 parts. So there are 2 charges. You need to find the electric field at the midpoint, right? One of that is positive, the other is negative. So the fields will add up. And the net electric field at the center is uh, due to one of the charge, it is 2.7 into 10 to the power of 6 Newton per Coulomb due to one charge. Okay. Due to both the charges, it is 5.4 into 10 to the power of 6 Newton per Coulomb. Okay. And the second part of the question, the force on the negative test charge placed is F is equal to 8.1 into 10 to the power of minus 3 Newton, or 8.1 millinewton. That's fine. Okay. Again, here many of you have done the problem properly. Very good. Some of you have done the solution, but missed it. You have missed writing the SI unit properly. Okay, so always remember to write the SI unit properly at the end of the solution. So that's about 23rd numerical problem. Then 24th is the potential energy of the system of 3 charges. Okay, you have a derivation of this, and the end result of that derivation can be directly used here, isn't it? U is equal to 1 by 4 pi epsilon naught within braces Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q3 Q1 by R31, right? That formula can be directly used here. So the answer for that 24th is 0.09 joule. 0.09 joule, or you can also write that as 9 into 10 to the power of minus 2 joule, or 90 into 10 to the power of minus 3 joule. All of that is fine. Okay, but don't forget the unit again. Next is last 25th, the capacitance of the plate. Yeah, you should make use of C is equal to epsilon naught A by D, and epsilon naught value is given to you in some situations, in some problems, but you shouldn't expect them to give. You should memorize the value of epsilon naught, right? 8.85 into 10 to the power of minus 12. So you should make use of that value and get the value of C first, and then Q by simply using the value, the formula of C is equal to Q by V. So Q becomes equal to, and the values, the final answers are C is equal to 17.7 picofarad, P 10 to the power of minus 12. Okay, 17.7 into 10 to the power of minus 12 farad. Q, the charge accumulated when it is connected to the supply, is 1.77 nanocoulomb. Okay, 1.77 into 10 to the power of minus 9 coulomb. Okay, so these are the answers. You just go through them once, and there is a task for you. Write the entire paper once as a homework. Okay, so it's for your uh, good. So you just write it once. Okay, uh, you can go through it just once. Okay, write it once, and you don't need to submit it to the college. You just send it through WhatsApp itself. We'll see it. Okay, and from the next class, from tomorrow, we'll continue the discussion on current electricity. Okay, thank you.